15 years of experience in IT overall. My initial years started with data warehouse, and later I have to explore BI and visualization, and then I got into Hadoop and big data space. So that's a brief intro about me, and if you can give me a brief intro about yourself, like what's your technical background, and what is the motivation that you want to learn Hadoop, it would definitely help me, tailor the courses later on. Yeah.
Okay, my name is Lata. I'm from New Jersey. My background is like I'm a technical writer, writing documentation.
Mm-hmm.
And the reason I want to learn big data is when I was working in a company, I was working for a big data group. So writing documentation for that group. So I thought, okay, if I knew something, then I could write better, So that's the reason I'm, interested in learning big data.
Okay. Right. So how good are you with programming language like Java?
Which one? Can you say that again?
Like programming languages like Java or any other programming language. Have you worked on? Yeah.
No, I don't know Java. So maybe slowly, eventually, if I'm still interested, I can, start learning.
Right.
Language.
Yeah, because when it comes to Hadoop, when it comes to big data, Java is not mandatory, but it is good to know.
Okay.
So for you, for a technical writing, you predominantly would like to know what is there in the big data. What are all the solutions are there in the big data, and how Hadoop is standing out as a one holistic solution, right? So all that can be done. I can definitely show you a demo, and on some of the things, but when we go for the sessions, I can definitely walk you through the different tools out there. What they have done is they understand. Not everyone knows Java. Okay, in case of Hadoop, they understand that not everyone knows Java, so they were able to come up with certain layer of tools which can help people like you or business users to write SQL kind of queries to process data and the process large set of data. Okay, SQL kind of queries or simple scripting, very plain English simple scripting, and yeah, things like that. So it is not mandatory that you need to learn Java, but there are tools that can easily help you to understand what is there with the Hadoop ecosystem as such. Okay. Generally, let me share my screen.
Okay.
It's totally new to technical writing kind of a profile. But generally, I work with developers, so if I am talking too much technical, or if I am not giving you much of context, please stop me wherever required. Right, I will make sure that I don't bore you with more technical stuff. Or right, so I hope you're able to see my screen.
Yes, I am. I'm looking at it.
So what do you, maybe just let me try to understand, because you already got this requirement because you had to work with people who are working in Hadoop or big data. So you definitely would have gone through and then gone through the net and Googled and try to understand what is big data and Hadoop and all.
Yeah, whatever they are talking while, attending the meetings, I was trying to understand, but I thought if I learned something, that would add more, so that's the reason.
Okay, what you understood from the term big data?
Yeah, so far I think like big data is something that it's a broad term for data sets, and it's usually stored in Hadoop, and something like HD, EFS, like Hadoop file system, something. Some names I remember, but not all. But so I'm trying to recollect.
So that is fine. I mean, generally, big data is something which is in large volume, right? Generally where we store the data, and we store the data in Excel, very simple storage. We store the data in text files. I mean, end users or business user will actually store the data in Excel, and the data size is huge when they have to deal with the multiple data sources. And what they do is they prefer to store the data in a database, and that too they will not store. IT will take care of it if they give the requirement. Correct. So they have to point to the source. Let's see, these are all the sources. I get data from web-related sale, and these are all the sources. I get data from retail-related sale or call center, based data. The data can come from different sources. For example, with regard to sales, if you just say this simple context. Compared to any other industry related item. Like sales is very simple to understand. So think of internet sales, think of service sale, and think of the, as I said, retail. So all this can come from different sources, can be of, sorry?
I don't see anything on the screen, like it says notepad, so I was just looking for anything like, what like.
Let me type it. Type it later and call center. Okay, I have PPT, but that talks about a lot of things within Hadoop and big data. But let me quickly share the context, some context, and then maybe I'll open up the PPT later on. Okay, so just assume that the sales are happening in different streams, different channels. Okay, the customer may say these are all the different channels from which I get the data, and what IT can do is IT can automate the process, right? IT means automation.
Information technology.
Automation. Yeah, automation means what they do. Okay, automation means they write ETL process, right? They go for ETL. What I mean by ETL is extraction, transform, and loading.
Right.
So get the data from different sources and transform the data in a more consumable form, and then they load it to database. Correct?
Right.
This is typically what they do. Okay, and this is again used for analysis and reporting.
Right.
Right. This is used for analysis and reporting. So mainly, if you see, even with the Hadoop or big data space, we are looking for storing data.
Right.
And then we want to analyze the data and come up with meaningful insights to take action based on the data that we have when we process the data and come up with some insights. So now this is stored in a traditional legacy databases, right?
Right.
What I mean by legacy databases, you can also say like SQL Server, Oracle, right? So what is the limitation with SQL Server or the legacy databases? You can store up to certain level only. Like it is actually one single server, database server. Like in TBs, XTB.
Okay.
So what if the data increases more than that, or if it is if the data is more, then what they do is they archive the data. So typically they keep only 2 years of data and archive the rest. Whatever old data is there, they archive it.
Okay.
Okay, so generally, this much of data, XTB I say, right? XTB is proposed for or predicted as a data growth or maximum data size that they have to handle for 2 years.
So, can I ask you a question?
So think of a situation. Sorry, I think I got disconnected for a while. Are you able to hear me now?
XTB, what does that stands for, XTB?
Let's say 60 TB,
Okay.
something like that. Okay,
Okay.
we'll say XSTB. Okay, so they say for 2 years I require 60 TB. So that is fine if the data is just going to be 60 terabyte. I mean TB means I'm referring to terabyte. So if the data is supposed, if they think that for 2 years I'm just going to use 60 TB only, and they are able to manage the data flow, and they are able to archive the data when it exceeds the whole data. They can be able to archive, and all that they can do. So the situation, if they're not predicting well, and if the web sales are going very high, just like they introduced. Okay, so there is a new product comes in the market, and they were able to introduce that, and they were able to do some R&D, and they're not able to predict. They didn't predict that the new product could could increase the sale or the number of visits to the site, or number of calls to the call center, the number of people visiting to the site or retail places. If it is going very high, and if they have to handle within 6 months. Within 6 months itself, they have to handle something like X6 TB or 60 TB of data. Then it's actually a problem, right?
Right.
And if it is keep on increasing, then how are they going to manage such a data growth which they didn't predict, right? So this is the problem now. So how do we solve this problem? Because the data size is increasing beyond the level they predicted. Now how they are going to solve the problem? Okay, straight away they can go to Hadoop straight away, or they can explore other options, right? So there are options to explore before they reach the stage that Hadoop can be a better solution for them. Okay, based on the context. So now if they now they say like the data size is increasing, and if it is only structured data that they have to handle, structured data. What I mean by structured data?
Yeah, structured and unstructured data, and something else also is there.
Semi-structured data. So structured data is nothing but simple tabular structure, rows and columns, well-defined columns. Okay, and semi-structured is something like XML, where the structure is, even though it is given explicitly in the tags, but it does not talk much about data type. It talks about data type, but it is not quite structured explicitly like in case of rows and columns. Like XML is, yeah, it has structure, but it's not that explicit as it is in the tables, right? So that is called semi-structured. And unstructured is something like binary files. For example, the photo or the video, where the information is stored as ones and zeros in binary format. So that is called unstructured. Even if you have a text file where you have a bunch of text, it is also unstructured, because there is no way you can classify that it belongs to a column or row, and nothing is there, right? That's unstructured. Complete text. Okay, so assume that the scenario here is structured data, and they're able to predict, okay, now now the data size is increased, it should not go beyond like a 120 TB or 120 TB, or or they're able to come up with a fixed size of requirement that they foresee. They're able to predict. If they're able to predict,
Okay.
what they can do is they can have multiple instances of the database, multiple instances.
Okay.
I mean, one SQL server to store data for year 2012, so 2015, 14, and another one for 2015, another one for 2013 or like that. They can partition the data and keep it in different instances. Okay, so this way, the problem can be solved if they know the data is structured and data is again limited to certain size. Are you able to get it? What I mean by partition? You divide the data and store the data in different instances based on year or based on country or any of the dimensions that they can think of.
Okay.
Right? So that is called partition, or they also call it as sharding. Okay, so put the data, split the data and based on certain specific higher level dimension, and then split it and keep it separately. So this way, this would solve the problem for them. This is one solution. So the data is structured and they know the data size that it can't go beyond this. They are very clear on that. So you don't have to suggest them Hadoop for this. Okay. So then, so again there is a requirement like they have to deal with structured data, but the data size can go beyond like terabytes, and it can go up to petabytes. Okay, go up to petabytes level of data size, and they mainly want to change the data warehouse environment they have. Data warehouse environment, right? I mean, this is ETL, and then you put it in database, allow the user to do analysis. That's what is the data warehouse environment. They want to enhance their data warehouse environment, and they see that the data size can grow up to petabytes, and the data is only structured. Okay, if this is such a scenario where the data size is really huge, but it's still structured, then you can go for something like MPP databases. Have you heard of MPP databases?
What is the full form for MPP?
Massively parallel processing.
No, I don't think. Maybe.
Have you heard of? No problem. Just saying.
Okay.
Greenplum, Vertica, and Teradata comes out of that, I guess. Have you heard of these databases?
Yeah, I know Teradata because I work for that team also. Because they're too technical and they need someone to document their databases regarding that screens and everything. When I'm listening to that, I felt I have no clue like what is the Teradata, what is this big data. So I thought it's better I should learn something and then start writing about it. Even though we have meetings, but it's better to look at or learn something along with, I can also participate and ask some more questions. If you know something, you can ask. If you don't know anything, you don't have any questions, right?
Right. So, yeah, all these databases comes under MPP. MPP is like massively parallel processing, and what I mean by massively parallel processing is massively stands for huge data set. Parallel processing means the data can be processed by parallelly. You will keep the data in different machines. It will not be restricted to one machine, multiple machines. So you will have a data spread across. I mean, the data or the structure will be there in multiple machines. Okay, and at times it is stored as columnar format, And I will discuss about what is columnar format and row format later on, but the data is just for assumption. I mean, for you to imagine it is, I mean, the data is not restricted to one machine or one big server.
Okay.
Okay. Typically, in this case, SQL Server, as I say, in this such cases, you will have one server for one specific year, right? One instance of server. So another instance for another year, something like that you are doing the partitioning. But here, but anyway, if you see, these are all exclusive databases, right? I mean, this is only for 2014. This is only for 2015, something like that. So here, you will have a group of machines. They call it as node, call it as cluster.
Oh, okay. I heard this way.
Machines or nodes. Okay, node is nothing but a machine, a box. So group of machine in a cluster. When you store the data will be stored across the cluster, and then when you retrieve the data, it will be very fast. Like billions of records, you can fetch it in seconds or minutes. It's not that possible. It's not possible at all with structured data and this SQL Server like instances or Oracle like instances. It is not, I mean, even it can't store more than more than 60 terabyte in some cases. I mean, it's only in the level of terabytes. So when you have to deal with a petabyte of data, or when you have to deal with huge data set, and then you want to quickly run any analysis or quickly generate some report, it is not possible with general legacy databases. But with the MPP like databases, it is possible. What they do is,
Okay.
they create, when you submit some query, it creates a plan.
Okay.
And distribute the plan to different machines, plans to nodes, and then when there will be one node which will aggregate all the results and then give it to the user. Okay, so it's like sending the plan or sending the logic to the nodes where the data resides and combine the results back to a complete output. So because it is happening in different machines separately in parallel, it is very fast also. Okay, it's not restricted to one machine, and this is, I mean, this way also we can solve the problem, right? So Hadoop is not the only solution for solving all these problems. One has to assess the situation, one has to assess the scenario, and then come up with a solution. So for this, MPP databases are sufficient.
Okay.
Correct. See, this is somewhat technical. I mean, some of the things are a little technical, but just understand. I just want to make sure that you understand Hadoop is not the only solution.
Yeah, because wherever I worked, I was working with more technical people, so that's fine because I'm trying to understand what they're talking, and that's how I can get it. If I have questions, I will ask. That's fine. You can.
Great. Okay. So think of the situation in another scenario where you have to deal with any type of data. Any type or specific type. Okay, I mean, it can be structured, unstructured, or semi-structured, but you know the type of the data. You want, okay, the type of the data. For example, the data is something like a document, or entire information about customers in one document, something like that. Or the information is coming from a sensor, the data is coming like a JSON format or specific format that the data type, but it's not structured all the time. Okay, and you want to, I mean, this is all something which is coming in real time. Okay, coming in real time, and you want to store it as soon as possible, as soon as the data comes, maybe like millions of inserts in a given time. So very fast insert need to happen in the database. Like general database like SQL Server or Oracle, when it is used for online processing, there is a limitation of how many inserts that they can perform or how many users can connect to the database. The scalability is limited. So, but you have to have such a scalability that maximum number of inserts, maximum number of users to connect to. For example, think of Facebook. Number of users log in and put messages. So there's such a volume. Or think of scenarios like, for example, there is one scenario like in hospitals, network of hospitals, they want to, track
Patients data.
yeah, heartbeats, pressure of the patient, and they want to push the information in real time to some database. Okay, track patients metrics, health metrics. Okay, through sensors, and they want to push it to a database as immediate as possible. And when they see there is a if there is a crossing of threshold level or of any specific metrics, they want to form alert. They want to raise some alert to the respective patient or to the family of the patient. In such cases, think of the situation where the data needs to be stored as immediate as possible, and some action needs to be taken as immediate as possible, right? If that is such a requirement, so we can go for something like NoSQL databases.
Oh, NoSQL, okay.
Like Cassandra, MongoDB, or Redis.
These are the names of the databases, or?
Yeah, names of the database. They comes in they comes with the different flavors of types. These are the names of the databases. NoSQL databases. There are types. For example, there is something called columnar database, column-wide NoSQL database, and there is something called document type NoSQL database. There is something called key value pair, key value type NoSQL database, and finally you have something like graph type NoSQL database. Okay, so if you see, based on the requirement, based on the type of the data, based on the scenario, one has to take a decision on which NoSQL type of database they have to go to. This is something as an alternative to OLTP databases. Alternative, what I mean by OLTP is online transaction processing, or something like real-time data storage, right? Where as soon as you buy a product, the data is stored in some databases in real time, something like real-time transactions. So as soon as the metrics needs to be, the data that is coming from sensor needs to be stored as immediate as possible in real time. So all that activity related databases, it can be an alternative to that, but there are some issues. Typical OLTP databases would comply to acid properties. Have you heard of acid properties?
No.
Acid properties is nothing but atomicity, consistency, and isolation and durability. It makes sure, these properties make sure the data is stored in a consistent way. Okay, but there are, these databases, NoSQL databases, does not comply to acid properties, but instead they fall under CAP theorem. I will explain in detail what all these when we start the sessions, but just to understand. So this talks about consistency and availability and partition tolerance. Okay, so so there are, if you see, even with NoSQL databases, you have different types of data, different types of NoSQL database to deal with the different types of scenarios. So it is not something a whole like a solution which is common to solve any problem. Okay, so user has to, yeah.
Yes, sorry. How do you
Go ahead,
decide
please.
which database you can use, like the column, document, or key value, graph?
Yeah, exactly. There is a confusion, right? I mean, how your end user will understand which database to go with, because NoSQL database itself is half different types, and there are a lot of database within each of these particular types, right? So this is, so I mean, this requires a lot of understanding of data and understanding of the requirement and to give a try and all that is there. So what I'm trying to understand, what I'm trying to tell you is, uh, NoSQL databases, even though it can store data like in petabytes, I mean, data storage is very good. You can, I mean, it's again something like scalable and distributed. What I mean by scalable is you can store any number of data, any size of data. I mean, you can keep on, the data is distributed across multiple nodes. Again, works in cluster. Okay, distributed. You can store. So, but the thing is, you need to understand. There is a lot of study needs to happen. Understand which data, NoSQL databases to go with. But the problem also here, it is actually for storage. Quickly, you can store and take some action. You can create alerts. So that is fine. But how do I do analysis? How do I do analysis? In a sense, I need to understand over a period of time what's happening, what's the trend, or some kind of analysis. Analysis is something which is driving anything and everything at this point. So these NoSQL databases are not doing very well with respect to analysis. So they have to go for some other tool. Okay, so that is the problem with NoSQL databases. NoSQL databases, the problem first is you need to understand what's your actual problem and whether which NoSQL databases to go with, right? And second thing is it's not very good with analysis kind of workloads, analytical kind of workloads. So you see, but if you think after the study, after understanding everything, you want to go for MongoDB. MongoDB is document type database. So you can store all the information in one document, one big JSON document. JSON, you know, XML, kind of XML, okay. You can store the complete info, for example, customer personal information like his address and all that, and his interaction with our call center, complete interaction information for a given customer, and his transactions, okay. All this information on one big document, okay. And when you have to have 360 degree of customers, you can just search by the customer ID and get complete information. Whether he contacted call center recently, what claims he has made, if it's a healthcare industry, what claims has he made, and where he lives is complete information, right? I mean, you can see the 360, you can have a 360 degree of information about customer, one customer, complete information. So like that, you know, you can store any customer information in a document based type of storage in MongoDB. So now, I mean, after you understand, I mean, if the end user or the company could understand, okay, this is what I need, they can go for MongoDB. But after understanding whichever is alternative, and after they understand that, you know, analysis cannot be that efficient, that they have to go for some other tool to do analysis, and they can go for NoSQL databases also, correct? So, but again, now if you see, Hadoop is not Hadoop is not only solution. Got it. So finally, they say, okay, I have to handle. I mean, here it can be any type, right? It can be structured or unstructured or semi-structured. Based on that, you can go for any specific data type. NoSQL types. So type is not a matter. Type of data, size of not matters, but it's not a holistic solution like that can solve any problem. You have one single problem, and that problem can be solved with one single NoSQL database, correct? So what is Hadoop? Hadoop is a kind of holistic solution. Okay, it has MPP flavor
Holistic solution. Okay.
within it. Within it, it has MPP flavor, and it has MPP database within Hadoop. It has data warehouse flavor, which is, so it has data warehouse flavor. It has NoSQL flavor also within it, which is called HBase. It is again distributed, scalable, and it is open source, free to use, right? And it can work in cluster with the nodes of cheap hardware. So all this makes Hadoop as a better solution at times beyond certain requirement. Okay, like I said, if somebody is having somebody is having problem in storing structured data, and they can, and then the data is limited, they can go for sharding or partitioning. There are different different things. I mean, they have to assess the situation and come up with what can be a best solution. Hadoop is something, a holistic solution, but you have to think of, you have to put a lot of, understanding of the business data requirement, or the business problem that you're trying to solve, or the data problem that you're trying to solve, and then come to Hadoop solution.
Okay.
You can deal with any type of data. But it's not all the time one has to go for Hadoop. That's very, very clear. Okay, that should be very, very clear. Like if you have data in, like in 100 TB, it can, if you're expecting data to go like petabyte or more, then you will go for Hadoop. For less than 100 TB, and if you have to deal with only structured data, then you can think of something else also. With the different types of data. I mean, as any type of data, when I mean the, the structured, unstructured, especially unstructured, semi-structured, any type of data. For example, the company wants to store all the legal documents, which is, not structured, right? Huge set of data. It can be anything, structured or semi-structured. So this is where you'll go for Hadoop. So Hadoop is something after, I mean, as I said, assess the situation, assess the problems, and then finally you will choose Hadoop if nothing is solving your problem. So that gives you an understanding that Hadoop is not the only solution, correct?
Right.
Based on the business, based on the use case, based on the problem that you're trying to solve, Hadoop may be one of the solution, but Hadoop solves the problem very good. If you think that Hadoop is the only solution, then you can definitely believe in Hadoop. You can definitely go for Hadoop.
You mean when compared to the other databases, like Hadoop is the best one, like, to solve the solutions or whatever?
Yeah, I mean, when you actually try different things, for example, you try to go for sharding or partitioning, okay, with a legacy, but the thing is, you are having a data volume problem, right, where you can't store beyond certain size. So what do you think of? You think of that sharding cannot help. Then you go for, then you think of what I can try. Then you are trying to use MPP databases, but MPP databases are costly. They're proprietary. You have to pay a lot.
Okay. Yeah, I know, licensing.
Then licensing, per node licenses there, right? Number of users based license, per node licenses there. And you can go for NoSQL databases, but NoSQL databases can solve one specific problem.
Okay.
It can solve, I mean, you want to have a MPP kind of a flavor where you want to do analysis, that's not possible. You can store huge data set, any type of data set in a fast rate, but you can't have analysis based flavors there. And that is, if you go for Cassandra, you can go for some other NoSQL databases if you want to change your plan. Correct. So I mean, there's something called vendor locking. You will get into one specific vendor and you will not be able to change later on, and trying to move the data from one vendor to another vendor is sometimes maybe a problem.
Oh, okay.
So if you go to Hadoop,
Mm-hmm.
it's like, after you go through all the problems, after you understand that all the three are not giving you a complete solution, then you'll go for Hadoop. But any point of time, if any of this can help you, whether the MPP databases can solve your problem, then you can just stop there. You don't have to come for Hadoop.
Oh, okay. Mm-hmm.
It depends, right? It depends. So, and no, Hadoop is something, if you think that, okay, nothing is solving my problem, Hadoop is my solution, then you definitely can believe Hadoop can help you. Because Hadoop is so matured at this point.
Okay.
Hadoop, when I say Hadoop and ecosystem tools, there are a lot of tools comes in on the top of Hadoop that can help you, like MPP kind of flavor if you want, it is there, data warehouse flavor is there, and NoSQL flavor is there. And I mean, one time you may have to use MPP, another time you may have to use NoSQL, and all that is there in one platform.
Okay. Mm-hmm.
Got it? So Hadoop, I mean, as you said, like it has HDFS and MapReduce. How do you store? I mean, you store a file in your system. It is stored in one file, right? One folder and one file name. But in case of Hadoop or HDFS, it is a distributed file system. Think of a file system think of file system which is spread across multiple machines. Okay, for you are actually seeing one folder or one file, but internally the file is split and kept it in multiple nodes or multiple machines. That is what HDFS is. Okay, for the end user, they see only one file.
Okay.
Internally, it is a spreaded distributed file system. Based on the number of nodes you have, based on the size of the file, it can spread across multiple machines. But how that all aggregated when you actually retrieve the file contents, and everything will be taken care by Hadoop file system.
Okay.
You don't have to worry about how the data comes back, how the data is spreaded. For you, just read the file as a single file that is there in your server. Just retrieve the data or filter the data or process the data. Nothing, no worries about how it is internally stored, but better to understand how it is internally stored when we discuss about architecture and all that. But simply, it is a distributed file system. So it is internally, like in all the machines, if you take the file system and then you put it like a ring, you put the file and it's stored somewhere in the node, anywhere in the node, and the file is split into some blocks, like 64 MB block or 128 MB block. Okay, so that is what HDFS is. Okay, and there are a lot of tools on the top of HDFS. MapReduce is a way how do you process the data, and you want to filter the data or you want to apply some logic there to the data and then process it. That is what is MapReduce. A simple way of programming using Java, but you can write your SQL using Hive tool. Simply pass SQL. Simply you write simple script using Pig Latin language, or so you can go for also workflow kind of a workflow and scheduling. Like you will retrieve the data and process the data and send it to another tool to do further split, further process, like workflow kind of things. You can go for Uzi. And if you want to store the data like a NoSQL database you can go for HBase. Real time, fast inserts. You have something like, if you want to get data from relational tables, relational databases like SQL Server or Oracle into Hadoop. Take the data from SQL Server or Oracle and put the data into Hadoop or HDFS. You can go for Scoop. If you want to get data from Twitter like Twitter streams, right? You can go for Flume. And there are tools like that, and there is a latest edition Spark. And then it's a replacement for it's actually fast processing of data and it happens in memory.
Oh, okay.
It is very fast. We will also discuss about it. Okay, so these are all the tools that we will discuss in our sessions. But if you want to understand any other tool, then you can definitely let me know. There are tools comes in I mean, these tools are something, for example, because Hadoop is open source, and somebody, I mean, like Facebook is trying to use it, and they see that, okay, it's good, it's solving my problem, I'm able to store the data, huge volume of data I'm able to store, but when it comes to processing the data, I have to depend on Java, but my employees or my workforce is not very good with Java. So what we are trying to do is we are trying to write our own code, or we are planning to come up with our own interface that anybody in our team can send SQL queries which will be translated to a Java code internally. So they come up with some interface. There is Hive actually. So they give it back to the open source community. So now anybody else can use it if they are using Hadoop. So like this, there are companies who developed different tools and they are giving back to the open source, contributing back to the open source community. So like that, there are a lot of tools out there. I mean, based on your use case, you can search for the specific open source tools that integrate well with Hadoop, and then you can use it. Okay, so but generally, to understand what is Hadoop ecosystem, you can just we can restrict to these tools, which are sufficient for understanding what is there in Hadoop or Hadoop ecosystem tools. Okay, all these we will discuss in our sessions.
Okay, sure.
So yeah, that's all. I don't want to go further. But I mean, I hope this gives you a context of what is Hadoop and what are all the things out there to solve the problem of data growth, right? So typically all this can be classified as 3 V's. You would have heard of it, 3 V's. Which is volume, velocity, and variety, right?
Yeah.
So to deal with each of these separately, then just think of these scenarios with think of these terms with the scenario that we discussed. Okay, so if you have only volume, if you have limited volume, and if you have structured data, then you can go for sharding or partitioning. Correct. Okay. Then if you think of so much volume and you want to quickly analyze the data and come up with insights, that is velocity. Okay, where you have to deal with data comes very fast, and the time that is required to analyze and give back the results is also limited, and you have to do it faster. So, and the data that you're dealing with is structured, so you can go for MPP, store the data in MPP databases and quickly write some Hadoop queries and come up with the result. So then you will go for MPP databases. Now the problem is, and in case of NoSQL, the data size is huge, and data type can be of specific type. It's not always structured. Okay, and the velocity is also something very critical. As I said, the data from sensors comes very fast. It needs to be stored immediately. Like it can be a million inserts in a given time. For such cases, you can go for NoSQL. So instead of going for, I mean, if the problem is something which cannot be solved with all the other things, and you still have some huge data set to deal with, and you have different types of data type to deal with, and the velocity is also very important, that you have to store immediately, or you have to analyze the data immediately, and I mean, you have to analyze the data faster. So all the problems, if together, if you have, in all these areas, then you can go for Hadoop, a holistic solution. Provided it, I mean, as I said, if it is not solved by other methods. So you got it now. So I hope you got the overview of it, but we will discuss in detail when you join the sessions. But I just want to make sure that you just want to clear some of the myth around Hadoop, that Hadoop is not the only solution.
Yeah, sure, definitely. And thank you so much, Raj. And